Hi, I'm Phil, and today we're going to examine the Grove TF Mini LIDAR. It's a product from Seed Studio, so we'll have a look at the principles to start off with, and we'll just scroll up to our description, and you can see a picture of how that's working. It can go from zero point 0.3 meters. Below that, it won't pick up at all. But from 0.3 to 12 meters, it's able to detect and give me the distance that an object is from the sensor. So the applications, I'm going to use it in robotics for sensing if there's an obstacle in front of it, but it can also be used for drones for altitude measurements. And other applications include getting the tank height and capacity of water in that tank, use it in physics experiments, or in even biology where you want to measure the height of a plant. And another interesting application is the theremin, where it could measure how far away your hand is from the sensor. And that can be used to control either the volume or select the note that you're interested in. So it's got some interesting specs, an operating range from 0.3 to 12 meters. And in that range, less than 6 meters, it has a 1% accuracy and a 2% accuracy from 6 to 12 meters. So let's have a look at the device. The interface, it connects to computers like an Arduino computer with a UART interface with both transmitter and receiver. So let's have a look at the projects. I've been working on quite a number, but the one I want to look at today is this one. We'll just look at the desktop arrangement, and you can see what it looks like here. So here is our LIDAR, and it's mounted on a servo, so it's swinging back and forward around about 180 degrees. So when the distance is less than 120, it will be red for the background, and it will be green if it's beyond 120. And the servo motor is driven by this Grove pulse width modulation driver board. And here is our computer, the Lotus Computer. So the objective is to use the LIDAR for measurement, and it will give us measurements of both the distance of the object and also the return signal strength. We'll get the results. We're going to show them on the Arduino serial monitor, and we're going to show it also on the Arduino plotter, which is on the Windows PC. And finally, we'll show the distance measurement and whether it meets the safety criteria on the LCD display. So we'll turn on that red if it's less than 120, and if it's more than that, will be green. And we'll improve the scanning because the device has around about a 3-degree angle. So anything outside of that, it won't pick up. So to get a good scan, we need to mount the whole thing on a servo motor. And for the design, we'll show that with if the distance is too close, we'll show that on the LCD. Hardware-wise, we're going to use the Arduino Lotus Computer, and just looking at some of the specs. So the Arduino Lotus is UNO compatible, so you can run all the programs directly using that. We're also going to use the Grove TF time of flight mini LIDAR, and we'll see the specs of that already. And we're going to use the LCD module and the pulse width modulation 16 channel. We need some Grove cables, and we're going to use one servo for this project and two for the next one. And here's our scanning LIDAR. So we might go across and have a look at the construction of that now. In the hardware construction, we start off with the Arduino Lotus Computer, and this is Arduino UNO compatible. But it's not only cheaper, I can buy this for about $17, and it has Grove sockets on board. So there's no need to add an additional shield for Grove connections. So what we do, we then proceed and add our Windows PC with the USB. This is where we do our programming. And also we go to monitor the progress of measuring distance of an object from our miniLIDAR. So we've got the miniLIDAR connected to ports 2 and 3 with a Grove cable. And then we proceed to show that data on a display. So this is the Grove LCD RGB Backlight, and it's also connected to a Grove shield. And we're going to add a Grove pulse width modulation 16-channel driver, and that will be connected to servo motors. In this case, we only need one. And here's our servo motor for the LIDAR. And later we can add an additional servo when we add a camera. For communications, we communicate at a baud rate of 9600 to a Windows PC. And that's where we show on the Arduino IDE the parameters that are measured and the angle that's scanned. Software-wise, we're going to use the Arduino IDE, and we've got the libraries shown here, one for each of the modules that we're connecting to the Grove sockets. And we'll have a look at the code of that separately. It compiled and executed, and we got good results. So you can see the Arduino plotter and the results on the Arduino serial port are shown here. So we're able to get the readings that we wanted. We could measure the LIDAR, both distance and strength. We're able to scan across, and we displayed the results on all those 3 devices. So we created a WorkSafe alarm. Issues, we have to make sure that the drivers, the library for our pulse width modulation is in the same directory as the Arduino program. And for references, we might go across and have a look at those now. So if you're interested, you can go across to the shop at Seed Studio, and they have a wiki on the LIDAR. And there are plenty of other references on LIDAR on the internet. And stay tuned, and I'll give you a desktop demonstration. So here we have the software in C++ on the Arduino IDE. And you can see that I've defined the hardware from the Lotus, the LCD RGB backlight, the miniLIDAR, the pulse width modulation driver for the servo, and I'm using one servo. And I'm defining the objects for our program. So right at the beginning, they're all defined. Then after that, I'm defining the variables. These mainly relate to the servo angle. And we're going to sweep across. Right at the beginning, we set up our serial port. and our LIDAR. And also that we then move on to the RGB. So you'll notice I'm setting up the colors for that. And I'm putting a message, WorkSafe, LIDAR. And in our loop, we call the horizontal scan, which is right on the bottom. So this is our scan horizontal direction, and I'm scanning back and forward in increments. Then the loop moves on, collects the data, and that is the distance of an object from the LIDAR, and it then prints that data out serially and calls display measurement. In display measurement, it shows distance, and it then shows the backlight. And I've set the minimum safe distance to greater than 120 centimeters. And the color goes red if it's less than that, and it's green if it's okay. So what we can do now is actually look at all of this on the monitor. So here is the serial monitor. See if we can bring that up. Plotter, and we'll bring the plotter across. So we're collecting data at the moment, and you can see as we sweep across, we're getting different distance measurements. So at the moment, when it's at a peak, we're at a safe distance, and when it's low, it's an unsafe distance. And that's the software and the monitoring of our LIDAR. This is the WorkSafe scanning LIDAR, and the device that's scanning here is the LIDAR, and it's a Seed Studio Grove TF Mini LIDAR, which is based on the time of flight, and it gives us a distance, and it feeds the data into a Lotus computer, which is Arduino compatible. So I've got another model of the Lotus. There's the Lotus computer with Grove sockets, and the mini LIDAR is connected via a Grove interface. The other two devices are on the I2C bus. So we have a Grove LCD RGB Backlight, and I've set the minimum distance to 120 centimeters. So the backlight goes red when it's inside that distance, and outside that distance it goes green. So you can see it's changing as it's scanning. It's getting different measurements. And the Lotus computer is over here, and we have a pulse width modulation board, 16 channel, and it's driving the servo motor for the scanning.